All right, it's already 6:05. Let's start the session. So again, everyone, thank you for joining us today. We're always thrilled to have you here in these OutSystems user group events. So whether you're coming from or you're tuning in from your home or your work or anywhere in between, yeah, I really appreciate your time. So today's topic is something a little bit different from the past topics that we have. So OutSystems meeting blockchain. We've got two speakers today. We've got Pedro Neto, our senior developer and OutSystems champion from Phoenix DX, and also Raphael Ranieri, who is an expert technical lead and, of course, an OutSystems MVP. Also from Phoenix DX, we are all here based in Sydney. So our speakers will be sharing about like how they leveraged OutSystems in a blockchain hackathon. Yeah, I never would have, thought that I'd say those kind of OutSystems blockchain hackathon in one sentence, but I have. So there's just a couple of things. So yeah, feel free to introduce yourselves in the chat. Let us know where you're joining from, why you're here. If you're a little bit more, yeah, just give us some highs and hellos in the chat. And if you have any questions during the talk, you can put them in the chat type them in. You're free to put in messages there, but I think that will all be answered at the end of the presentation. So with that, I'll hand it over to Rafa and Pedro. Take it away.
Thank you. Thank you very much, March. Thank you everyone for joining as well. I am Raphael, like March said. And today we will be taking you guys in a journey where OutSystems meets blockchain, also known as Web3. Just to explain a little bit of how we will do that and what will happen. First, I will explain what sparked the idea of using OutSystems with blockchain. We used it in a hackathon after all. Then I will also introduce our solution, the solution we did for the hackathon that's called Frankie. After that, Pedro will also talk a little bit about some blockchain concepts, and finally, a hands-on demo where we will show how to go from deploying a smart contract in the blockchain to using it to mint an NFT in OutSystems. We'll also talk about the Forge components we created to help anyone else that wants to do the same. And in the end, we will also have some Kahoot questions, guys. So stay until the end to make sure you participate on those ones as well, okay? So just to start with where this started, right? This all started with a hackathon called Block Magic. The idea behind this hackathon was to raise awareness around blockchain development and attract more developers into the ecosystem of blockchain, okay? It was sponsored by Chainlink in partnership with Polygon and Avalanche, which are big names in the Web3 space, and it had multiple tracks as part of the the hackathon as well, like a track for gaming, another track for enterprise. So we had a lot of different tracks to participate on as part of this hackathon. Now, on another subject, Pedro and I always talking about building games and doing experimental side projects. So that's why we also got interested by the blockchain and NFTs and this type of subject. And we would often talk about it, about doing some side projects, but never actually got to doing something, right? And then Pedro came across Blockmagic, the hackathon, and saw the perfect opportunity for us to make it happen, put in practice everything that we wanted, right? So he called me up and said, hey, let's do it. Why not? Let's finally build something cool, right? And that's where our journey began. Early in our planning, though, we realized, okay, we can code, but our UI skills, not so good, right? So we decided to also invite Robbie, who is this person you are seeing here on the screen as well. He's one of our colleagues on Phoenix EX and a fantastic designer as well, by the way. And we asked him to help us to turn our messy ideas into something users would love, right? And that's how, Frankie, our solution was born. And just a fun fact for everyone as well, before I dive in details about Frank. The name Frankie is actually inspired by Frankenstein, right? Because just like the monster was made of different parts, Frankie, our solution, lets you assemble NFTs by mixing and matching different traits, okay? And don't worry, we will explain what all those terms are during the presentation. You might not know what they are, but anyway, this is the idea behind Frankie, our solution, right? It's essentially a platform that allows users to create their own dynamic NFT collections on the blockchain. It's built to support all kinds of use cases. So since gaming to art to just for fun stuff, anything really. The way it works is you can define your own trait categories like a body, eyes, accessories, rarity for your NFTs. And Frankie takes care of generating unique NFTs based on random combinations of those traits, okay? Everything is stored on-chain, on the blockchain. And we use smart contracts to interact with the blockchain. And the users can then use a clean front end built with Outsystems to create those collections, okay? So just for everyone's benefit as well, I just want to say that the code is available on Forge. So if anyone wants to have a better look on the details, how it works behind the hood, feel free to download it from Forge, okay? And without further ado, let me actually show you how it looks. So let me go through Frankie, our solution, to make sure everyone really understands what happens, okay? So let's start with the fun part. Actually using Frankie. We will start here by actually creating a new collection. So I will go to my Frank's lab.
These are Forge component, na?
Yes, it is a Forge component, Manisha. You can download from Forge if you want to see the code.
Whose environment developed the O11 or ODC?
This is O11 for now.
Yeah. Oh, thank you.
Okay. So just to start showing what I am doing here, I am going to my Frank's lab. Like I said, the inspiration is from Frankenstein. So we try to keep the environment a little bit similar as well with the story. Okay, so we have a laboratory as well. Here we can define the name of our collection. So I will use Outsystems user group sample or maybe collection as my collection. I will define an NFT price as well. And this will be explained later on as well, guys, why we need to define a price here. And I will click start mutating. Now, when I clicked started mutating, you can notice that prompt was shown here for me was presented to me asking me to sign a request. This was done by MetaMask, which is a browser extension. We will explain more about it later on the presentation as well. But essentially what's happening here is that MetaMask is asking me to sign a transaction to interact with the blockchain and really confirm I am who I say I am. Okay, so I'll just confirm here to make sure everything is well defined, and we can see now the first screen to create our collection. Here on this screen, it is the place where we can define our traits. The traits are the specific qualities that our NFT will have. Okay, so for example, you can see here we have some different categories. The appearance ones are traits that have a specific image that can be shown in a visual way. So what I will do, as images says more than 100 words, right? I will actually start adding here some traits. So I will first of all create a body that will be our NFT body. I have some SVGs here that I left prepared for my presentation. So let me just create 4 bodies. I will give a name for each one. So this one will be the blue, yellow, pink, and white. I can also define a chance of this specific trait appearing when minting, when generating the NFT. So in this case, since I want all of them to have the same chance of appearing, I will just define 25% on all of them, and then I will create save. Once I do that, you can see here that I have my trait defined. I can also see it on the right side. If I click surprise me, it will randomly try to give me another trait from those 4 options I defined. And then next, let me also try to add another trait called wink, because I want to show a very cool feature as well. So I will add here 4 winks. 1, 2, 3, and 4. I will also give a name to each one. So green, pink, right? And yellow. Now I will say all of them will have 25% of chance of appearing as well, as I want all of them to be equal. And I will save. Now, you might notice here on the image that the wing is actually on front of the body, right? And that's not really what we want. We want the wing to be out behind the body in this case. So that's why we have those arrows here. With those arrows, you can change the order of the layers of your traits, especially the visual ones. So you can see now it is on, it's behind the body. If I click surprise me again, you can see it will try to in a random way, give me a full image combining all of the available traits. Let me just add a couple of more just to show how it works. I will add here eye, actually. Maybe eye is better. It's the door for our soul, just to give some personality to our NFT. So I will use here the normal eye. These are little buttons, so I will say it's the buttons eye. And this one will be just one, so it will be the Cyclope. That's a good one. So I will again define more or less the same chance of them to appear. It's important to note, guys, that the sum of all the chances needs to be 100%. So that's why I defined 34 here and 33 for the other ones. So let me save again. So there we go. Let me also add mount. Oops, sorry, mount here. This way, if with the AI, if someday we can make the NFTs game live, they will be able to also talk, right? We never know. Okay. So I will also give a name. This will be the fang. This will be the mustache. And this will be the happy mouse. 34, 30, 33, 33 again, like I did before. I will save. And now we can see that we have all those traits being randomly chosen to define an NFT. These are just previews, okay? We are just seeing a preview. It's not the actual NFT, but it will work sort of the same way when we try to mint the NFT in the blockchain. Just a quick note, we also have different types of traits where we can define other options like that are not visual, for example. So if you are using in a game, you could use the range to define a trait that is called, I don't know, life, that will go from 10 to 11 to define the range your character or NFT can have on that specific attribute. So there is a couple of other options that you could use, okay? I'm happy to talk about those offline, but just to make sure we will have time to go over everything, I will not talk about it right now. And once we are finished setting up the collection, right, all the traits, it's time to actually deploy it to the blockchain. So what I will do now is click here on publish. This means that we are about to write a new smart contract on the chain that stores all the collection metadata. So all this information you saw here. Again, MetaMask pop-up here appeared. It's our connected, like I said, crypto wallet. It lets us sign transactions and confirm the deployment of the contract in the blockchain. Okay, you will see that we have some amounts here, which will be the fee I need to pay to do it on the blockchain. We will explain all of this in more details later, but I will just confirm. You will see that the messages here will start changing, and some more confirmations will appear for me to do as well. So here you can see another signature request. By the way, Pedro, like I said, we'll explain in more details that later on the presentation. And behind the scenes, something that I would like to also say is that we are using Ethereum, which is a .NET library that helps us interact with Ethereum, the Ethereum blockchain, okay? It's what takes the data we define it here in the Outsystems environment and actually writes code on the blockchain, right? It's like our, let's say, bridge between platforms on server side, okay? Our smart contracts as well have different methods like the add trait. To add each trait we define it, the set collection info to save the overall metadata for the collection, and later on as well, it will have the mint method, which is used to generate NFTs. These methods is what we call programmatically from Outsystems as part of our deployment process, okay? Now, blockchain transactions sometimes can take a little time, especially on the test networks that I am using. Oh, in this case, it was pretty fast. Okay, so I can either mint one here to show you how it would work in a real scenario. However, I want to actually show a more complete collection we already have here which more traits. I think it will be a little bit more interesting to see. So in this collection, you can see that we have a background trait, a wing trait, a body, eyes, mouth, jumper, and also a crown, right? Clicking surprising me will change, okay? And if we want to mint then an NFT for this collection, what I can do is come here and click mint. Once I do it, let's call our NFT. We need to give a name. Outsystems user group NFT. Did I write it right? Outsystems user group NFT, and I will click on mint. So when we did that, when we clicked the mint, what we are doing is that we are triggering a blockchain call that randomly selects traits using something we call Chainlink VRF, which we will explain as well, by the way, later on the demo, but it's what we use to generate the randomness in the blockchain. And once I confirm them, it will go to the blockchain, create everything we did, and here it is. Let's give some minutes. So there we go. This NFT is now stored on-chain, complete, with a unique combination of the traits we defined earlier. It has its own token ID, it has its own metadata, and a visual that's assembled using Outsystems hosted images as well, which we will make sure to explain later during the presentation. And something else I wanted to show, of course, is that since we are using standards, in this case for our NFTs, like the standard ERC721. This is a NFT standard that is open, it is global, okay? And since we are using it, this NFT is fully compatible with marketplaces like OpenSea, for example. So what you are seeing here is the OpenSea marketplace. It's a well-known site to sell and buy NFTs across the blockchain. And it means that it can be viewed, traded, or even integrated with any other Web3 applications that supports NFTs in these standards, okay? Which, by the way, opens up endless use cases for games, art, collecting, and all the possible scenarios, right? So this is the NFT we just generated. If I click here, you can see all the traits it has. If it was traded or sold before, it would have a price history as well. This case is just a test, so we will not have any information, but this is now on the chain across multiple nodes, which normally is people computers, right? And yeah, I think that's what I wanted to show related to Frankie. I will now stop presenting my screen and give the stage to Pedro to talk a little bit about the concepts of the blockchains and show as well the components we created. So Pedro, are you there?
Yes, I am.
So
yeah. Thank you for that. I think it went very well. It's very good for a test net. And so I will share my screen. And so now, as Rafa said, I will go over some of the blockchain theory before jumping into the components that we created and how we use them. So basically, a blockchain is a network of computers, and they are all running the specific blockchain software. For example, Bitcoin or Ethereum. So each computer in this network will run that software, and that software will basically validate transactions that are sent to the network. And this validation is made through an underlying technology, and the most known ones are the Bitcoin and the Ethereum one, and they are called proof of work and proof of stake. So this mechanism is what makes the blockchain secure, and the way that all of those nodes agree on what is the correct data. So, and once a group of transactions are accepted, a new block is added to the chain. So some basic properties of the blockchain, and very important, are these ones. And the first one, it's that it is decentralized. So by being decentralized, it means that there is not a central point of authority. And so it also means that you wouldn't be able to corrupt any data just by yourself. You will need all of those computers to agree on that invalid data, right? So another very important feature is the traceability. So all transactions are public on a blockchain, and therefore they can be traced. So also, every blockchain has a blockchain explorer by default, and the existing ones already allow you to filter by address and follow all of these trails, like where the crypto tokens came from and where they are at any given moment. And for instance, in the 2016 Bitfinex hack, authorities recovered 3.6 billion in Bitcoin by analyzing transactions patterns and linking them to suspects. So usually blockchain and crypto is used by many scammers, but then even they could perform the hack and get some value from it, then it becomes very hard for them to take the money out of the blockchain. Because at this point, they could be traced to their real identity. It doesn't mean it's impossible, but it's just not hard. It's just hard. Then another property is the blockchain is immutable. So once a data is on chain, it will never be changed. And a very important piece of this is that each block relies on the previous block hash. So if I was running a node, for example, and I would go into my node and hack into that block information and saying that my wallet has more data than it really has, this would create a new hash for my block, and all the subsequent blocks will be invalid. So the network wouldn't accept any blocks from me anymore. Also, the information is transparent, so it's very similar to the traceability. So because it's public, you can go on these blockchain explorers and access the data at any given time. And because of this, it's very secure. Because of all of these properties, the blockchain is secure. It's easy. It's hard to tamper with. It's easy to trace, and all of the computers must agree on the data. So it's very secure. And now going to another concept of the blockchain, which is the wallet. And the wallet, as Raphael showed some interactions already, is basically this plugin that you can install on your browser. And this will be the MetaMask plugin, for example, that is used to interact with EVM chains, and EVM is Ethereum virtual machine. I will go into more detail later. And basically, the wallet is the door for any user to interact with the blockchain. So in the example that Rafa showed, it was a final user that was interacted with the blockchain and minting a new NFT for him or creating a new collection. But we also had some wallets in the background, like in the backend, performing an admin role. So every time you want to interact with the blockchain, you will use a wallet. And so on a wallet, you can see the balance of a wallet. In this case, this wallet has 0.3 Ethereum, which was roughly $70 at the moment. It also shows the connected chain. In this case, we are connected to Arbitrum 1. And yeah, a lot of things here. You can also see the activity of the wallet. And besides all that information that you can see, what a wallet does is the signing of the transactions. So before submitting transactions to the network, the wallet will sign those transactions for you. And this signing is done through cryptographic techniques using private and public keys. So you will sign a transaction, the transaction will send to the network will be able to identify that it's really you that are sending that transaction. So yeah, it uses public keys and the private keys. And the public key represents your public address. It represents you. So it's like an hexadecimal string. And if I want to send coins to any other person, I would use this wallet, this address. And the private key is internal. It's stored on the wallet, and it's what is used to sign these transactions. And there is also this concept of hot and cold wallets. So MetaMask, for example, is a hot wallet. So it is a software wallet. It is online and is very easy to use and accessible, as we have seen here. And the cold wallet is a hardware wallet and is offline. And it, because of these reasons, is typically safer. So you would use this cold wallet, for example, you will use to store your tokens in the long term, and the hot wallet, like MetaMask, you will use on everyday transactions just to interact with the blockchain on different applications. So another very important concept about the blockchain is smart contracts. And smart contracts is executable code that is deployed on chain. And what we are seeing here is a Solidity language, and it's one of those contracts. So, and a smart contract has all of these properties, and in this case, the ones that we are using, they are EVM compatible. So EVM means Ethereum virtual machine. So, and there are multiple chains that are EVM compatible. And this means that this same contract written in Solidity will run and can be deployed on any of these chains. And for example, we have Frankie on Avalanche network, but there are also other networks, blockchains that are EVM. And these ones are Polygon, for example, and Ethereum, of course. So similar to a blockchain, smart contract is immutable. So once you deploy it, you will never be able to change that. And this brings up some challenges because you won't be able to fix bugs immediately sometimes. So there are some techniques to overcome this, but typically you need to replace the old smart contract with the new one and somehow tell the applications that they should use the new one and somehow invalidate the old one. But I won't go into detail at this point. And they are also Turing compatible, complete. So this means they can solve any problem that can be solved by computational algorithm, regardless of how complex. So possible sometimes means not feasible. And in the blockchain space, everything has a cost. So if it has a lot of computational cost, it becomes unfeasible. A smart contract also has a public address. So similar to any account, it will have a public address, and that's the address where you will be interacting with the smart contract. And every time you interact with a smart contract, especially if you are changing the data, this will require gas fees. And similar to accounts, a smart contract can hold balance. And this means you can have balance on the smart contract and then manage these tokens depending on your use case. For example, in Frankie, we have a concept of a pass NFT, which represents the ownership of the collection, and then this pass is managed by another smart contract, and this smart contract is, when you mint, you interact with this smart contract, and the crypto tokens that you use to pay for the mint go to this smart contract, and then the logic there will determine which addresses it will pay royalties and stuff like that. So as Raphael briefly explained, we have some components on Outsystems. We have this one that is Ethereum. This one is based on an existing .NET library, and it communicates with the chain on server side. We adapted to Outsystems, and it exposes some functions, as we can see here. We are not exposing all of them, but we exposed the ones that we needed for the hackathon. And then besides this component, we also have another one, which is called EVM Smart Contracts MetaMask Connector. And this one will allow you to interact on the browser, like popping up the MetaMask and asking to sign the transactions right there. And also this has some actions. So as you can see, you have the MetaMask utils. This will be used to interact with the MetaMask, and then OS Web3. So this is an object that will be injected by MetaMask, and it also allows you to interact with the blockchain. And so now I will show you how we could use this client-side component on your applications. So for that, we have created this simple Hello World code program. So this is a Solidity code, as I have explained before. And this platform is Remix, which is Ethereum IDE. So this allows you to code EVM compatible smart contracts. And so I have this hello world, as I said before, and we can see here the compiler that this will trigger an error, an alert if this had any errors. And when you compile, it generates these output file, these files, and that will be used later on. And also, we can also deploy the smart contract through this platform. So in this case, I have no deployed contracts, but I could really quickly. Yeah, so the contract is already deployed. I was just not connected with the wallet. So when we deploy a contract, it will exist at a specific address, as I've said before. So as you can see, the hello world is already deployed in this address. And then we created the program to interact with this smart contract. So the first thing, let me just disconnect here. So when interacting with the smart contract using our component, the first thing you'll need to do is to connect the MetaMask to your Outsystems application. And to do that, we have a block. And once you connect the MetaMask, you will now have your address in your application, in your Outsystems application. Then to interact with a smart contract, you will need the address of the smart contract and the ABI of the smart contract. So the ABI is application binary interface. And as you can see, it specifies like the methods, the functions that are defined in the smart contract, what type of inputs it has, what type of outputs it has. So this will tell our object how to interact and how to prepare the data before submitting the transaction to the network. So here I would create the object. And once the object is created, so now I have a JavaScript object here on the browser. And now I can say invoke the smart contract. And I will say just call this function, which is the hello world, and it will reply with hello Outsystems user group. So this part, this string was sent to the smart contract, and the smart contract replied with the hello world and this string. And similarly, we have another way to interact with the blockchain and the smart contract. And so what I've showed you before was a call function, and this requires no transaction to be sent to the network. That's why we didn't see the MetaMask pop up. And on this case, we are only querying the data that is on the blockchain. But if I want to set a name on the blockchain, and I will call it Outsystems user group, for example, and this will create a transaction, it will prepare the transaction, and now it will request the MetaMask to sign that transaction. And once you confirm, you, the user, this transaction will be signed and broadcasted to the network. So after one confirmation, I know that this information is stored on the blockchain, and now I could invoke this other method, which is just a query. And this says, okay, this didn't go so well. Okay, so it took some time. Actually, it wasn't really confirmed after one confirmation, but this varies on depending on the network that you are on. So as you can see now, it's showing Outsystems user groups. And if just really quickly over the contract, over the code. So here is the Outsystems page. Here we are using the MetaMask login block, which is on our component. So you just need to drag and drop this to the screen, and it also has the connect button and all of that. And once you connect, it will trigger some events, and usually you will store the address so that you can later determine some of your ad, like the connected wallet. You can detect if their balance, the NFTs it has. So, and then you could react and show stuff on screen accordingly. Then the second thing, I have these two input fields, which will hold a text variable. And then the second thing you typically want to do before interacting with the contract is to create a JavaScript object using this method. So this receives the address of the contract, it receives the application binary interface, and returns an object. Then you must keep this object in memory or wherever you need to store it. In this case, we are keeping it in the memory in a local variable. And then after that, you can interact and invoke transactions on it. So if you want to call a method, you would use this call methods, and this will only query the blockchain. And also, if you want to send a transaction and change the state of the blockchain, then you would use the send methods. So all of them, both these methods receive the contract object, the method name, and the list of arguments. And I can show you here, for example, very quickly on the set name button. So what we pass is the smart contract object, which is the object I've just created, the set name, which is the method or the function that we are invoking on the smart contract, and then argument list. And in this case, it only receives one parameter. So that's it regarding the contract. And now just to finish. So NFTs usually are more associated with this kind of collections, so very speculative assets, but they are more than that. So an NFT is a non-fungible token. A non-fungible token means that it's unique, and its token cannot be its value cannot be directly inferred. So on the opposite, so there are non-fungible tokens and fungible tokens. A fungible token would be $1, for example, that you can change $1 for $1 for another one, and you still have the same value. On an NFT, you wouldn't do that because the value is given by other means. So another cool aspect of NFTs is that they represent this unique digital ownership, and it's something that has never been done before. Like, you could copy files So, and everyone has this file, but with NFTs, you can really prove that you are the owner of a specific asset. And as Raphael told before, an NFT is represented by the standards, ERC 721 or ERC 1155. And it's what is this that allows you to interact with all the ecosystem that is built around it. And we had some more slides here, but I'll just go quickly to the end. We also wanted to talk about the generator. So the computation on a blockchain is deterministic. It means that every node needs to get the same output from the same input, right? And then they all have to agree to then have a final agreement and create a block. So how do we create randomness in such conditions? So Chainlink, which is a company, it created this, and is the one that was promoting this hackathon. So Chainlink created this VRF mechanism, and VRF is a verifiable random generator, and it's something that will generate a unique random number for that particular request, and will share that number with all of the instances of the smart contract that are running on different computers. And then using that, you have random in a blockchain. And so we didn't win the hackathon, but we had a complete working prototype, which we shown. And it's the dynamic NFT maker, which is Frankie. We had a sample game, very simple game that would use these NFTs. We received some positive feedback, and we also created some Outsystems components, and we are proud of this. We want everyone to use these components, and so in the end, I think we still win. And yeah, basically that's it. So do you want to add anything, Rafa?
No, as you said, we were very proud of the solution at the end, even not winning. And I think we can open to questions if someone has any questions as well, right?
Yeah.
Any questions, anyone?
Any questions? Well done, guys.
I think we can do the Kahoot questions then, Marge.
Let's do it. Yeah. Let me just prepare my screen. I will start sharing. Ready to present. Oh, one more click. All right. All right. So to those of you who are not yet familiar with Kahoot, so join at www.kahoot.it and then enter this game pin, which I will also share on the chats. Five, 9, 9, 6, 2, 5. And I must say, Raf and Pedro prepared very tricky questions. So I hope you were all listening. These characters kind of remind me of Frankie. I'm giving everyone a few more minutes. Didn't know we've got maybe the brother of Elon Musk. We've got Elon Musk in the call. Oh, I see Stu. Sunil, Victor, Edu, Joyster. I think we can start, right? Okay. I'm gonna click the button. Yeah, this you have 20 seconds to answer. And the fastest who can answer the question correctly will get the highest points, but you'll still get points if you get the correct answer, but not as high as the fastest one. Right, we've got a few more coming in. Okay, give 10 more seconds. I think there's more people coming in. Got 16 players. Okay, I think that's all, because we've got 18 in the call. If my math says me right, I think it's all good. Okay, pressing the start button. The first question. Right, we've got 8 questions. The first one: which of these is a key benefit of blockchain? Centralized permission control, native machine learning support, immutable and traceable transactions, or reduced transparency? See, it's very tricky. Just the first question. All right, we've got 12 people getting the correct answer. Victor is on the lead, followed by Edu, and we've got Mr. Musk. Next question. What is the main difference between hot and cold wallets? I'm not gonna read the options, it's too long, but I don't know if I have a preference, hot or cold wallet.
Depends on the weather.
If it's got money or not, right?
If it's Melbourne, it's cold.
Oh, there you go. Hot wallets are connected to the internet. Cold wallets are offline. So that's the main difference. We've got 10 people answering it correctly. All right, we've got Edu at the top. We've got Elon, and we've got Stu. Next question. What 2 elements make blockchain wallet security possible? Public key and private key, seed and token, email and code, contract, and signature. Ooh, a bit tricky. So public key and private key. Got Elon at the top now, followed by Victor, and our son has the highest answer streak, 3. Well done, guys. Next question, 4th question. Which server-side component is used by Outsystems to deploy contracts? Forge Connector Studio, Data Grid, Deployment Aggregator, or Ethereum? Did I say that right? Ooh, another tricky one. See? It's super tricky. It's the green one. I don't want to say that word again. Okay, we still have Elon at the top. Up 3 places, we've got Sia or Sha. as the highest climber. Next question. Which client-side component does Outsystems use to trigger smart contracts methods? Blockchain events, MetaMask plugin, EVM smart contracts MetaMask connector, blockchain wallets. And it's the yellow one. All right. Iron at the top, and Stu is back as in the leaderboard. All right. Sixth question. What is the purpose of using Chainlink VRF in smart contracts? Generate secure and verifiable randomness, store data off-chain, encrypt wallet addresses, or speed up transactions. Got 3 more seconds. It's to generate secure and verifiable randomness. Ooh, Stu is leading at the top, followed by Edu and Hiren. It's gonna get a bit trickier. Where's image content hosted in Frankie's NFT architecture?
So this one is a bit unfair since I didn't have the time to go over this. Yeah.
But still, there were 5 people who got the correct answer. So on Outsystems servers. All right. And ooh, the last question. Here we go. What does an NFT's metadata typically include? Traits, attributes, and reference to the image, token balance and transaction fee, the user's wallet seed phrase, the contract deployment logs. 4 seconds. And another tricky one. So it's traits, attributes, and reference to the image. Let's see who won. On 3rd place, we've got Victor. Well done, Victor. And Edu on 2nd. And who's the first one? We've got Stu. Well done, guys. Thank you for joining. So if for the winners, please, oops, not that button, but please send me an email, margaret@phoenixdx.com, to claim your prize. Yes, Manisha?
Can you share the recording in this session?
Sorry?
Can you share the recording in this session?
Yes, that will be shared. Yeah, it will be shared in the Outsystems platform as well. Yeah, where you access the user group details. Yeah.
Thank you.
Awesome.
Thank you very much, everyone.
Thank
Mark.
you. Thanks, Rafa. Thanks, Pedro. Thanks for your
Thank you all.
Thanks, Raphael.
amazing,
Thanks, Pedro. That
amazing
was
guys.
awesome.
Thank you, everyone.
Thank you. Bye.
Thanks.
Bye-bye.
Bye.